Alright students, so now we're going to do page 96 of the notes. This is hypothesis testing for mu, the mean, the population mean, when sigma, the population standard deviation, is known. It's not a very commonly realistic case. Usually if you don't know the population mean, then you also don't know the population standard deviation. However, it's a great place to introduce the theory of hypothesis testing. So we have x be a random variable that's appropriate to your application. Always define your variable. And then you obtain a random sample of size n of x values from which you compute the sample mean x bar. And the value of sigma, the standard deviation of the population, is already known, and this is often maybe from a previous study. So often they will use a previous population standard deviation. In hypothesis testing, you always want to set up your null and alternative hypothesis and set your level of significance. If x bar is distributed normally, then we can have any sample size. Okay, n does not have a limit on it. However, if it's not distributed normally, if you don't know that, then you need a sample size of at least 30 to proceed with this procedure. You can either use the critical value method or the p-value method, whichever you prefer. FYI, your test statistic is z equals x bar minus mu divided by sigma divided by the square root of n, and then of course we decide whether we reject or fail to reject h naught, and then we write a conclusion. Now it's really important to note here that when we fail to reject the null hypothesis, it doesn't mean we accept it, and this is because you cannot accept single values. All we're testing for is to see whether the parameter mu is plausible. A confidence interval gives us a range of plausible values. Okay, so we can't just focus in on a single one. So that's why we always want to talk in terms of our alternative hypothesis and never use the wording we accept h naught. You don't want to say that. Now a note in your calculator, if you have a graphing calculator, you'll be going, if you choose to use your calculator to assist you in hypothesis testing, you'll be going in your stat menu, and then you'll be locating your test tab or application within that menu, and you'll be finding your single z test. Let's get started with an example. Okay, this is example 8.8. So this x is going to represent the number of sunspots observed for a 4-week period, and we've got a random sample of 40 such sunspots from periods from Spanish colonial times. We have x bar equal to 47, and sigma, the standard deviation, is somehow known to be 35. So they were thinking that the mean number of sunspots per 4-week period was about 41. And they think that maybe sunspot activity is linked to climate change. So they want you to test if the data indicate that the mean sunspot activity during the Spanish colonial period was higher than 41. They want you to use an alpha level, meaning level of significance of 0.05. So step 1 in any situation is to, of course, set up your mean. I'm sorry, your hypothesis. Mu is going to be what they're claiming. They were claiming 41. HA is what you suspect is going on, or what they asked you to test. They asked you to test if it was actually higher than that. So higher than symbol is a greater than symbol. Now if you're doing critical value method, you need to look up a critical value with alpha being 0.05, and this is a one-tail right test. So one tail, and it's a right test. And if you're using the critical value method, you'll need your tables. If you're using the p-value method by hand, you'll need your tables too. I'm doing the critical value method in this example. In the critical value method, we're going to go to our little cheat table, hypothesis testing critical values. We're going to look up a z right tail, alpha 0.05. the critical value is 1.645 from that table. Then we're going to plot it, and we're going to shade our rejection region. Okay, again we're doing the critical value method in this example. And in this method, after you get your critical value and your rejection region set up, you need to calculate your test statistic. So 47 minus 41 divided by 35 divided by the square root of 40. And that's going to equal 1.08. Okay? And then you want to see, where does that test statistic fall in your picture? Does it fall in the rejection region, or does it fall not in the rejection region? Our test statistic falls somewhere right here, which is not in the rejection region. So our decision then is we are going to fail to reject H naught. And we're going to conclude, based on the evidence, the mean number of sunspots activity, or I'm going to say sunspots during the Spanish colonial period, might as well be descriptive, was not significantly what? We were testing to see if it was higher than 41. So we're going to say not significantly higher, or you could say greater than. Higher than their claimed 41 and an alpha of 0.05. Okay? And we are done. That was the critical value method, 5 steps, testing mu when sigma is known. Okay? Stay tuned and we will be testing for when sigma is unknown.